Question 11. Consider the function y is equal to 3 cos of 2x plus 1. And then for A, sketch the graph of this function for 0, x is between 180 and 0. Now, you are going to need to use your graphics calculator here. So I would straight away plot this on my graphics calculator because that's going to help you a lot. And I put it in the function here, y is equal to 3 cos of 2x plus 1 already in. Notice I've got my window. If you just go to the window here, I have got my x minimum goes from 0, it goes to 180. I've got my scale. That means that, as you can see, I'm going up in tens here. I've got my scale is at 10. I've got my y minimum is going from -5 to 5, going from down below here to above there. And I've got my x scale going up in ones, and then so I've got my window, and then if I plot it, you see I get this shape graph like that. So that will help you to draw your graph. But let's just have a look at this equation. Now you've got y is equal to 3 cos of 2x plus 1. Now what is the 3 showing? Well, that's giving you amplitude. So you know that your graph is going to have an amplitude of 3. The 2 is giving you your period. So remember, the period is equal to 360 divided by that number multiplying the x. So it's going to be that, so it's 180. And that's why you can see here in my graph that I have got one full cycle going in 180. But now it's a matter of positioning my graph, because we've got the plus 1 over here. And that plus 1 basically is going to just shift your whole graph up. So because I've got a cosine graph there, I've got something like this, like that shape there. If I had no plus 1, then this would go from 3 to -3. But because I've got a plus 1, it's adding 1 to everything. So this will make this actually go to 4 and -2, like that. And therefore my zero value, my zero axis, would actually come down there like that. So I'd have something like that, and we would have that position there. So this line at 1, this line at 1 over here is sort of the new line where the graph is symmetrical about. It's like that, and we see it goes to 180. It's going to start at 4, as we can see. It's going to go, the minimum value that it's going to be is at -2, so I can put a line across there. The maximum value that it's going to go is at +4. We're going to have that at 180, sorry, at 90, it would be over there. Let me just do in a different color. There, it will be there. And we would get our shape at 180, it's going to be over there. At 60, it's basically at half. You could put in your values here, but you're going to be basically like this. So we're going to get something like this graph over here. It's going to come down. It's going to cross just 10, 20, 30, 40, 50. It's going to cross just after 50. This is 180, so it's going to cross just after 50. So I need to go down more. Let me just redraw this a bit. It's going to go through there just after 50, and it's going to go through here. This is 180, this is 170, 160, 150, 140, 130. So it's between 120 and 130. So 120, 130, it's sort of going to go through there. So you're going to have your graph is going to do something like this, like that. Okay, you want to make it a nice smooth graph. Hopefully you'll do a better graph than I am. Then it says write down the period of the function. Well, we've already got that. We've worked that out already, so that's 180 degrees. And then it says using your graphics display calculator, find the smallest possible value of x between 0 and 180 for which 3 cos of 2x plus 1 is equal to 2. Now we know that we have got this graph here is our f of x, or is equal to our y, which we've just drawn. So we are looking for when this is equal to 2. So what I'm going to do here is I'm going to draw up the line here, y is equal to 2. And that would equal this one over here, this line over here. And then it says find the smallest possible value for x. So we're actually looking at this point over here, that point over here, for when the two are equal. You see, because of that point over there, y is equal to 2, and also y is equal to 3 cos of 2x plus 1. So that's when both of them are equal. So I will put this into my, I will plot this in. So I'm going to have y is equal to 2. I'm going to say graph, and there we have it. And then we're going to trace it. And now I can go, I will need to go this way. And I go all the way to the intersection. And I've got there, I'm pretty close. Y is equal to 2.07. Y is equal to 34.46. Now we can see that it would probably be a little bit further, so 34.5 would probably be fine. 34.5 would probably be a good value for that. So that's that intersection point. 34.5. That is when y, well, that is when this equation over here will be satisfied.